Hello, Celeste. So in this video, I'm going to go over how to, without a calculator, find the vertex, the x-intercepts, and also the y-intercept of a function so we can get a very accurate graph, again, without the use of a calculator. So we'll start with the vertex, and I'll go through two different methods that I can get the vertex from this equation. First off, you do need to know what because I'm going to refer to standard form a few times, and you know what the standard form of quadratics are, because these letters will be important coming up. Our standard form, the coefficients are ax squared plus bx plus c, where a, b, and c are just the coefficients that match up to these numbers. So vertex method number one, to get the vertex of this graph, there is a known formula, and it comes from the quadratic formula, which you'll see here in a little bit as well. But there is a known formula for the x value for the vertex. The x value for the vertex of a quadratic is negative b over 2a. So for this quadratic, and again, there's no coefficient right here in front of the x squared, that's an understood 1. For this quadratic, a is 1. B is 5. So the x value of this would be negative 5 over 2 times 1, which is just negative 5 halves, or negative 2.5. Now, if I want to get the y value, I just take this x value and I plug it back in. So the y value would be f of negative 5 halves, or negative 2.5. You can use a calculator to do just the computations if you need it, but that's negative 5 halves squared plus 5 times negative 5 halves plus 4. All I've done is take every x in the original equation and replace it with negative 5 halves. And I can compute this pretty easily. This is 25 fourths, positive 25 fourths, plus negative 25 halves. So I'll write minus 25 halves, plus 4. And if I want to combine this into one fraction, we need a common denominator. So I'm going to go with the denominator of 4. So 25 halves, I want that 2 to be a 4. Multiply it by 2. If I multiply the bottom by 2, I multiply the top by 2. So 25 halves is the same as 50 fourths. Those are the same fraction. 4, or 4 over 1, I multiply the bottom by 4 and the top by 4. So 4 is the same as 16 fourths. And now that they have a common denominator, pretty easy to combine them. 25 minus 50 is negative 25, plus 16 is negative 9. So the y value is negative 9 fourths. So the vertex would have an x value of negative 5 halves and a y value of negative 9 fourths. Or negative 2.25. Did I get that right? Yeah. Okay, this is one method to get the vertex. I'm going to show you an alternate method. So method number two. Method number two to get the vertex is to convert the equation into the vertex form of quadratics. So this is called standard form, the ax squared plus bx plus c. The vertex form, just make some room over here. The vertex form is y equals a times x minus h squared plus k, where your vertex is going to be hk. This is just taking the parent quadratic function and moving it right and left h units and up and down k units. So let's do it the second method and see if we get the exact same answer. Hopefully we do. So this is going to use a method called completing the square, where I'm going to take this equation, x squared plus 5x plus 4, and I'm going to convert it to make it look like this equation. So I got y equals, there we go. And we'll clean this up a little bit. So I'm going to leave some space with the plus 4, and I'll explain what completing the square is. Completing the square is turning this into a perfect square trinomial, and to do that, we're always going to add half of this value and square it. So half of 5 is 5 halves. Squaring that is 25 fourths. But if I added 25 fourths to this side of the equation, I also have to subtract 25 fourths. Because now I'm adding 0, right? And I'm allowed to add 0. I can add 0 without changing stuff. Well, this is a perfect square trinomial. It is the square root of the first term, the sine of the second term, and the square root of the last term, which is that 5 halves that we were expecting. And then here, again, got to combine these two. 4 minus 25 fourths. I'll rewrite the 4 as 16 fourths, so I can combine those without a calculator. Common denominator. And 16 minus 25 is negative 9, so negative 9 fourths. And now that it's in this vertex form that it matches here, your HK, remember this minus H, so it has a negative. So if I see a plus sign here, it's the opposite. So your x value is negative 5 halves, and your y value, that's a plus k, so whatever sign you see out there, it stays the same. Your y value is negative 9 fourths. So 2 different ways to get the vertex. Now the x-intercepts. So I'm going to clear all this, and we're going to talk about the x-intercepts. The easiest method to get the x-intercepts is to factor. Not all equations will factor though. So factoring is only useful in certain cases that the numbers work out well enough. But method 1, we're going to factor. And thankfully this one will factor. So when I'm factoring x squared plus 5x plus 4, that's y equals. When I'm factoring this, I'm looking for 2 numbers that multiply, and it's always going to be the setup. 2 numbers that multiply to a times c and add up to b. So 2 numbers that multiply, in this case a is 1 and c is 4. So 1 times 4 is 4. So I'm looking for 2 numbers that multiply to 4 but add up to 5. Okay, and there's not a lot of options to multiply whole numbers to get 4. I could do 1 times 4, or I could do 2 times 2. On one side, I'm multiplying. On the other side, I'll add them. 1 plus 4 is 5. 2 plus 2 is 4. And the mystery I was trying to solve is to find 2 numbers that multiply to 4 but add up to 5. Those numbers are 1 and 4. So what this allows me to do is it allows me to rewrite the equation in its factored form. Instead of writing x squared plus 5x plus 4, I could write x plus 1 and x plus 4, because those numbers are a positive 1 and a positive 4. Now, how does this help me get the x-intercepts? Well, x-intercepts always occur when y is equal to 0. So all I'm going to do is take this equation and set it equal to 0. And if I'm multiplying 2 things together to get 0, the only thing you can multiply by to get 0 is 0. So one of these 2 factors has to be 0. Either x plus 1 equals 0 or x plus 4 equals 0. Each of these will give me one of the x-intercepts. X plus 1 equals 0, the opposite of adding 1, subtracting 1. So x equals negative 1. That is one of your x-intercepts. The opposite of adding 4, subtracting 4. X equals negative 4 is the other x-intercept. This is one way to get x-intercepts. But not every equation will factor. So this method won't always work. If it doesn't work, then we have another formula that could be used. This famous formula to get x-intercepts is called the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And before we start substituting in 1, 5, and 4 for a, b, and c, I do want to point out something from the vertex formula that I mentioned earlier. This part right here, the negative b over 2a, this is the vertex. This is the x value for the vertex. And because there's two x-intercepts, and you'll see when we look at the graph, because there's two x-intercepts, there's an x-intercept to the left of the vertex, the minus, and there's an x-intercept to the right of the vertex, the plus. So the negative b over 2a is the x value for the vertex, and this scary square root tells me how far left and how far right I move from the vertex to get to the x-intercept. Okay, so let's take these values, 1, 5, and 4, and plug them in for a, b, and c. And let's see if we also get negative 1 and negative 4, just like we got by factoring. So b is 5, so negative b, negative 5, plus minus square root b squared, that is 5 squared. I'm going to go ahead and write that number now. 5 squared is 25, minus 4 times a is 1, c is 4. I'll go ahead and write that down too. 4 times 1 times 4, that is 16. All over 2 times a, this case a is 1, so that's just 2 times 1, which is 2. I'll clean this up a little bit before I take up my whole board with this problem. 25 minus 16 is 9. And the square root of 9 is 3. 3 times 3 is 9. So here are my two answers, negative 5 plus 3 divided by 2, and negative 5 minus 3 divided by 2. We're going to figure out both of those, the minus answer and the plus answer, and then write down our final answers. Negative 5 minus 3 is negative 8. And if I take negative 8 and divide that by 2, that is negative 4, one of our x-intercepts. Negative 5 plus 3 is negative 2. And if I divide that by 2, that gives me the other x-intercept of negative 1. So I have both my x-intercepts, and I did it two different ways. We have the factoring from earlier and the quadratic formula. Both of them give me x-intercepts at negative 1 and negative 4. And remember, our vertex is at negative 5 halves, negative 9 fourths. Now finally, to get a good graph, I'm going to put those points, I'm going to put them on the graph just to get a good sketch. And I'm also going to include the y-intercept, just because at this point. Now the y-intercept happens when x is 0, just like the x-intercept occurs when y is 0. So the y-intercept, this is easy, means x is 0. So all I do is I go to the original equation and I replace x with 0. So 1 times 0 squared is 0. 5 times 0 is 0. So the y-intercept is just the number that's left here at the end. The y-intercept here is 4. Okay, so let's get all this down to get a good, accurate graph to conclude this video. So we want a nice sketch of what this quadratic would look like. So this is going to be the graph for y equals x squared plus 4x plus, I got those mixed up, plus 5x plus 4. I'll write down the key features that we've talked about so far in this video. I have a vertex at negative 5 halves, negative 9 fourths, which if I get the decimals, I'm trying to do this in my head, negative 2.5 and negative 2.25. The x-intercepts are located at negative 4, 0, and negative 1, 0. And then finally, the y-intercept is at 0, 4. So we're going to take all these points and put them on the graph. So I have my y-intercept at 0, 4. I have one x-intercept at -1. I have another x-intercept at -4. And remember when I was referencing the quadratic formula, because all quadratics are symmetric, the vertex is always right in between them. And what's halfway between -1 and -4? -5/2 or -2.5. And the y, it has a y value of -9/4 or -2.25. So a little bit between -2 and 3, closer to -2 though. And all I have to do with these 4 points is just connect the dots. And we have a nice, pretty parabola for our quadratic. So this is the graph of x squared plus 5x plus 4 without the use of a calculator. And a few different methods that you can use. Pick your favorite and apply it to whatever other problems you want to work on. If you have any other questions or need help, please feel free to message me for other stuff. Thank you.